Continuing with our training and test set that we created, we can do a simple linear regression. And the syntax for linear regression is the formulaic syntax where the outcome variable is written first and then tilde the predictors. So the set of predictors can be, we can identify specific variables, or we can just identify everything, or we could say we just want only a few of those. So for example, in this first model, we are regressing our total.value as our outcome variable on the square foot and living area. So this is the syntax lm, and then the outcome, the predictors outside after the tilde, and then the data set that we're working with. So once we run this, ours going to create a reg1 object which will store all of these things. So if we kind of even take a sneak preview in this object, we have coefficients, residuals, effects, rank, fitted value. So it creates a whole set of things. And again, because we have the $sign, we can access any of these components from our regression object. To see a quick overview of our regression results, we can use the summary function. So we get this output, but notice output is basically a text file. We can't really do much with it. But then the broom package has this tidy function, which will result our output as a table or as a tibble that can be imported and used in the data set. So if I do tidy, then we get tibble. So I could have saved this as an object, as a tibble. Then we can actually export this tibble into a CSV file. From there, bring it in Excel, and we can edit and modify it and make it look nice. So the basic coefficient estimates, the standard error, then the test statistic. Again, the null here in the regression setting is that none of this, the coefficient on lot square is 0, and the test statistic is a t-test to test that hypothesis. Similarly, the estimate for living area is 0.13. The standard error is this, and our t-test is that the coefficient, or the beta 2 in this case, because beta naught is a constant, beta 1 is the coefficient on lot square feet, and beta 2 is the coefficient on living area, that this is 0. This is the test for that. We reject the null in both cases. So even though our estimate for lot square foot was 0.0008, we reject the null that this is equal to 0 at a very high confidence or very low p-value. So our test statistic is 31 for this test. Glance also lets us see quick. So once I've created my regression object, I can use glance to just see all the statistics that this saves. So we have r squared, adjusted r square, which is basically r squared but a penalty for number of coefficients being added. Then again, the p-value is for the overall test of significance, that none of these coefficients matter in our regression, only constant matters. If we wanted to have an interaction between lot square foot and living area, we can use this asterisk. Again, we are piping this into tidy. So once we pipe this, we see that we have these individual parameters, lot square foot, living area, as well as the interaction of the two. Now, if we only want the interaction term, then instead of the asterisk, we will explicitly call out that colon. Colon will just have the interaction of the two. So this could be the case when I wanted to include, let's say, lot square foot and the interaction of lot square feet and living area, but not want to include living area. We could have had lot square feet plus lot square feet interacted with living area. And if we kind of see its result, we have just the interaction of the two terms. Now here we have a bunch of predictors. If I look at my data set, we have all of these predictors. Let's say we want to include everything except just two, except tax and year build. Then this dot shows we have everything except for our outcome variable, but then we are excluding the year build and tax. So if we run it this way, we see everything in our regression except for our year build and tax. So we have 11 features that we are regressing on instead of 14. So here, let's say we want to run this on our training set. So instead of running it on our full housing, we are now running this on the training set. So we get a different model on the train set. Now this model again contains the coefficients, fitted values, and residuals. Augment will add these onto our data set. So this is a very powerful command when we want to include the predicted values as well as the residuals along with the data set. We use the augment command. So we have this training prediction that we created. This has our actual y value, then our variables that we included in the regression, as well as the fitted value, the residual, and then a bunch of other statistics. So standardized residuals, etc. So augment will include the fitted values and the residuals, which is essentially our yi, which is this, minus yi hat. So this is our residual that augments it into a data set. Now let's say we want to just have the predictions and the actual values. We can then use the helper functions or the in dplyr select against selects given columns. So now we have just our total value, our fitted value, and residual. We don't have to have all the additional variables. Again, augment is a way to pull out the fitted values and residuals, and then we can decide which columns to include by using the select function. Now what if we want to use our model that we got on the train set to now predict the prices in the test set? So we'll use the command predict, and notice the key argument here. We'll say new data test data frame. So now this model will use our parameter estimates from our training and use these to predict the value, total value in our test set. So here we get the predicted outcomes of our test set. Again, these are randomly selected because we had done a random sampling of 80 to 20%. 80% of the data set went to the training set, and the 20% went to the test set. We can also augment the outcome. So now that we ran this model, we can augment. Again, reg3 is our regression model that we ran on the training set, right? This is our reg3. Now R saves the coefficient estimates of this model in the object reg3. So when we click on augment, or we run augment and we supply the new data set, so what's going to happen is that the coefficient estimates from this object reg3 will be used to predict the outcome in our test set. So this is doing multiple steps in just one go. We have created a reg3 object, ran in the training set. We use those estimates to now predict the value on the test set. So these are the fitted values, again, 316, 507, 359, and we see that these are the same that we got here. So we have covered the basics of regression. We've covered quite a bit. We started by partitioning our data into training and test set. In this video, then we saw how we can run a simple regression a multiple regression model with various combination of our variables. We can include all variables. We can include only a couple of variables. We can include everything but a couple of variables. We can also include interactions of our variables with each other. And then we can also control whether we want the individual interacting variables to be included as well, or just the interaction term. And once we have done that, we also saw how we can then use that model to predict the outcome on our test set. Later on, we'll look at regression diagnostics to see if that model was a good fit. But for now, this is how we can partition our data set and then do a multiple regression, choosing the variables we want to include, and then use that to predict our outcomes in the test set.